Okay, now we must see this example, these three examples. They are giving us another logical situations. Okay, let us start with this one. A ball of mass 25 kilograms moving at 20 meters and 12 meters per second was brought to rest under constant deceleration in 4 seconds. Calculate the work done. Now, remember this deceleration, it means that always how there is a change in kinetic energy because there was change in velocity. Okay. So now, this is telling us that a body is 12 kilograms, so they are leaving us mass. So we have our mass as 25 kilograms. Our initial velocity, U is 12 meters per second, was brought to retardation in 4 seconds. We are leaving us T equaling to 4 seconds. So there are two ways you can do this number. Either use the first of all, you can use the equation of motion. But the easiest is to use the idea that work done is equal to the change in kinetic energy, and so they will change the kinetic energy down. The moment you see that the vehicle was decelerating, it means that now the initial speed was higher than the final velocity. So what do you do there? It means that you get now u squared minus v squared because the initial was higher than the final because of the deceleration. Whenever the vehicle is decelerating, it means that it's going to lower its speed. So from there I say work done, work is equal to change in Ke, which will be now half m into u squared minus v squared. Why am I starting with this? Because there was also kinetic energy. Because the speed was lowered, so that's why I'm starting with the u. Because this one was bigger than the final because of the deceleration. So, from there now I can say my work from here is going to be a half, then the mass times 25 into now my initial velocity which is 12, then minus this one which is the final because it was brought at rest. RV is going to be 0 meters per second. So here my work done, you just get this one to the calculator. So here was 1800 joules. As simple as that. Because of deceleration. This was because of this deceleration. If there is acceleration, then this one is on the starts. If there is acceleration, then we start with D. If there is acceleration, we start with B. As simple as that. Okay. A body of mass 4 kilograms is moving with an initial velocity of 5 meters per second. So our U is 5 meters per second. The mass is 4 kilograms. Full stop. If they change the kinetic energy of the body was reduced by. So here, whenever they say reduced by, it means that they are giving you the change. So this is the change in the kinetic energy. Remember the word by and then 2. If they say 2, now that was just the real. But if they say by, they are giving you that actual change. So this is the change now. Because they say by, so meaning that our change in Ke is going to be equal to 16 joules. In the distance of 40 meters, they are giving us a distance 40 meters. Find the deceleration. Not find acceleration, we shall use the formula v squared equal to u squared plus 2as. So to get the solution, we have this, but we don't have this. So we are missing this. So we first get this. So what are you going to use? We know that change in work done. Okay, they are giving us the change in the kinetic energy. So we say change in kinetic energy, change in Ke is always equal to a half. Now, because there was deceleration, it means that I'm going to start with the u because of the deceleration. So m into u squared minus v squared. I need this. But I'm starting with u because there was deceleration. If you start with the v, you are going to get a negative answer. So you start with always this. show that there is a deceleration, there was a lower in the speed. The moment you are lower than the speed, always the change is going to be u minus, because there is a loss. So whenever I say there is a loss from time, can I start with u? So the change they are giving us 16 is equal to a half times the mass, which is 4, into u, which is 5 squared minus b squared. So you see, by these two, so I have 8. I have, this is 2 divided by this, I have 8, equaling to 25 minus b squared. And from there you can see that my b, okay, from here you can see that my b squared is going to be, when I take this side and I bring this side, if you get 8 minus 25, you get 17. So my b is going to be 17 meters per second. So after getting b, now I can come and put it here so that I can get my deceleration equaling to u squared plus 2as. Now my b squared from here is 17 equaling to 25, then plus 2a into our distance, which is 40. So from there, our deceleration of course is going to be negative, because that is, so when I get 17 minus 25 divided by 8, so the answer I'm getting is negative 0.1 meters per second squared. Forces are now decelerating, that's why we have a negative there. The body of mass 20 kilograms was pulled at a uniform speed. So whenever I see uniform speed, it means that there was no acceleration. A distance of meters on a rough plane inclined at 30 degrees by a force acting along the line of the slope. If the coefficient of friction between the body and the surface is 0.2, find work done against friction. Okay, we first now sketch. So I come with my sketch here. So I'm going to see that that's going to be my, so it was covered, this was the distance here. Let us say our body is now here. If our body is there, we are going to be having reaction. And then this spring was inclined at 30 degrees. So this body was moved at distance of 20 meters. So that is our distance which this body was moving. Okay, so of course it's going to be having some weight. This is going to be the weight of the body, which is going to be 20 g. You get the mass times the gravitational. So remember, this one is also going to be based on this angle, and then if you resolve this, this will be 20 g cos 30 degrees, because we had our friction, so then the coefficient they are giving us already. So allow me to cross this here. So meaning this is going to be my height. From there it's going to be my height h. Okay, so from there, know that work done against friction, part A, work done against friction is given by mu r, then the distance moved. Now here be careful. The distance moved was from here up to here. Then we need the r. From here you can see that our r is that. So you can see that if you resolve, the perpendicular plane, our r is going to be 20 cos 30 degrees. As simple as that. Okay, so you have r, they give us mu. From there they give us mu as 0.2. So then we substitute our done here. It's going to be 0.2 times 20 into 9.8 cos 30 degrees, then times the distance moved. This was the distance moved 20. So whenever you are, that's why we are having this to work done against work done that work done against friction. Work done against the friction, you move in the distance covered. But what banana did is gravity. You base on the height which was moved. That's the difference. So when you press that to the calculator, shall be having so here I'm getting 678.9639. Sorry, these are yours. Okay, now when I come to part B, work done and then it's gravity. Alright, our work done and then it's gravity is equal to MDH. Now this one is the height. You always be careful, this is the height. Okay, so meaning we need this height here. So how are we going to get that height? Okay. So if I'm to draw this, if I'm to draw this diagram there, if I'm to draw it here, so that I can see the way I'm going to get height. So this one is 20 meters, and this is my height I'm looking for. And this one is 30 degrees. You see what it is? I have this, I need this. So from there I can say that our sine 30 degrees is equal to the opposite over 20. From there I can say that my height is going to be 20 sine 30 degrees. When I sine 30 degrees is a half. So our h will be 20 into a half. Our height will be 10 meters. After having that, we come and substitute in here. So my mass still the same as 20 times 9.8, then times 10. And so there my answer is going to be 1960 joules. So there's a lot of work to do, and then it's gravity than to do against friction. So that's how we handle that, members. I wish you well.